The agents that survive contact with production almost never run end-to-end without supervision. Whenever the model is about to do something with consequences, send an email, run SQL delete, charge a card, you want a human in the loop first to review, approve, or correct the planned action before it happens. LangGraph's interrupt mechanism is built for exactly this, and the shape is always the same. The LLM proposes, the human disposes. Here is the one idea, and it stands on the last lesson. You declare which nodes should pause, the graph stops mid-flight, persists its full state via the checkpointer, and waits. Because the state is durable, the process can sleep and the pod can restart, and a later resume reads that saved state and picks up exactly where it stopped. Let me walk the code beat by beat. First beat, you arm the pauses at compile time. You pass interrupt 4 with a list send to stop before that node runs, and you can pass interrupt after to stop right after a node finishes. Crucially, you also pass the checkpointer because interrupts only work with one. Forget it, and the graph raises an error with nothing to pause into. Second beat, the run hits the wall. Take the canonical email agent, a draft node where the model writes the email, then a send node that actually calls the API. With interrupt for send, you call invoke with the user's intent, the graph runs draft and then stops, returning early with the draft sitting in state and nothing irreversible done. Third beat, you detect the pause and show the human. You call getState and snapshot.next being non-empty. Here it points at send, means we paused, so show the review UI. An empty next means the graph finished. Fourth beat, the human acts and resuming is one line. If they edit the draft, you apply it with update state, passing the corrected field for this thread. Then you call invoke with none and the same config. That none is the entire signal. No new input, just resume from where you stopped, so the graph picks up at send, runs it and finishes. And notice the elegance. The graph code never had to know about the human. The interrupt is a runtime concern, not a node concern. The same three primitives, interrupt before or after, update state and invoke none, cover every variation. Approve, reject with guidance, or regenerate a draft. Authorize a specific risky tool call. Ask a clarifying question and resume on the answer. Even multi-stage approval with a different reviewer at each node. And interrupt after is the mirror for audit rather than safety. Pause after a node to log full state, spot check a result, or run an eval before moving on. One sharp warning to close. If the human step accepts edits from a web client, every field flowing back to a tool is now untested input. So constrain what update state can change and validate the diff server side. A fully autonomous agent is a great demo and a risk to ship. One human gate is the difference between the agent helped and the agent sent 4,000 wrong emails overnight.